Hello students, how are you all doing? Hope that you must be fit and well. Today we are doing a sum from JEE Advanced Paper 2016. The sum reads like this. Let f maps R to 0 to infinity open interval. That is 0 and infinity are not the elements of the codomain, and G maps R to R be twice differentiable functions such that f double dash and g double dash are continuous functions on R. Suppose f dash 2 is equals to g2 is equals to 0. F double dash 2 is not equals to 0 and g dash 2 is not equals to 0. If limit of fx into gx divided by f dash x into g dash x as x tends to 2 equals to 1, then the four options for this answer of this question are given. A. F has a local minimum at x equals to 2. F has a local maximum at x equals to 2. F double dash 2 is greater than F2 and Fx minus F double dash x is equals to 0 for at least one x element of real number. Out of these four given options, there may be more than one correct answer, more than one correct option for the given question. Okay, so we have to find all the correct options as the answer for this question. Okay, so see how we will do the sum. See here. Here we are given that limit of fx, okay, into gx divided by f dash x, okay, into g dash x when x is tending to 2. Its value is given to us as 1. Now see here, when we are putting x value equals to 2 in the left hand side, okay, so what we are getting, okay, if I am putting directly the value of x equals to 2 in the left hand side, so the limit will become then f2 into g2. For x you will put the value 2, okay, and divided by f dash 2 into g dash 2. Now see here, f2 in the question it is given to us that f2 the value is not given, but g2 value is given to be 0. Okay, so this is f2 into g2 value is equals to 0. So it is f2 into 0. Okay, and f dash 2 value is given to be equals to 0. So in place of f dash 2 I am writing 0, and g dash 2 value is not equals to 0. So that is g dash 2. Okay, so it is equals to g dash 2. Okay, so what we are getting, so 0 multiplied with any number is equals to 0, divided by 0 multiplied with any number is 0. So this become the 0 by 0. Okay, so when the function becomes 0 by 0, we use the L'Hospital's rule. Okay, so how we use the L'Hospital's rule? So the limit will become, so the LHS, okay, so the limit will become, okay, x tends to 2, you will differentiate the numerator and the denominator separately, okay, and the ratio of that, okay, will be the okay, so that is the limit is equals to the differentiation of numerator divided by the differentiation of the denominator. So differentiate the numerator, so this is the product of the two function. Okay, so this will be, okay, first function as it is into the differentiation of the second function, that is g dash x, plus the first function differentiation into the second function, okay, gx, divided by the, here also apply the product rule. So here it is the first function, okay, into the differentiation of the second function. So the g dash x differentiation will be g double dash x plus the differentiation of the first function f double dash x into g dash x. Okay, so that is equals to limit value is given to us as 1. Okay, now put the value of x equals to 2 here. Okay, so we will have f2 into g dash 2, correct, plus f dash 2 into g2, okay, divided by here it will become f dash 2 into g double dash 2 plus f double dash 2 into g dash 2, that is equals to 1. Okay, now we will put the values of these. Okay, now we will here the values are given. So f2, okay, now f2 is not given the value, so we will write f2 as f2. Okay, and g dash 2 is also not equals to 0, so it is just told to us that it is not equals to 0, so we are writing g dash 2 as g dash 2 plus f dash 2 value is given to us 0, so this is 0, okay, into g2 value is also equals to 0, so that is 0 into 0 divided by f dash 2 value is 0, so that is 0 into g double dash 2 is nothing being told to us, okay, so that is g double dash 2, okay, plus f double dash 2 is not equals to 0, it is given to us, so that is f double dash 2 into g dash 2 is not given, okay, the value, so it is g dash 2, so that is equals to 1. Okay, now see here, so what we are getting from here, okay, now from here what we are getting, so this become equals to f2 into g dash 2, okay, and 0 multiplied with 0 is 0, so no need of writing 0, okay, and here 0 into any number will be 0, so this part will be 0, okay, so plus this will be this only, okay, so f double dash 2 into g2 is equals to 1. Now the cross multiply, okay, or okay, now the cross multiply, so what we are getting here, okay, oh sorry, here it was f dash 2 actually, here it was g dash 2 actually, so here it was g dash 2, okay, so here g dash 2 is both in the numerator and denominator, so we are cancelling that g dash 2, okay, because that is not equals to 0, so we can cancel it, because g dash 2 is not equals to 0, in the question it is given to us, okay, so you can cancel from here, okay, so what we are getting from here, f2 is equals to f double dash 2, okay, so cross multiply, so f2 is left here, so f2 is equals to f double dash 2, so what we are getting here from here, f2 minus f double dash 2 is equals to 0, okay, so here the d, here it is saying that fx minus f double dash x is equals to 0 for at least 1, so we are getting for x equals to 0, fx minus f double dash x equals to 0, okay, for at least one value, so for x equals to 2 we are noticing that it is equals to 0, there may be many other values, so d is correct, okay, now we have to check from these remaining, so now see here, c cannot be correct, because here it is telling c f double dash 2 is greater than f2, they are equal actually, because the difference of these, and from here we are noticing f2 is equals to f double dash 2, here in the c it is telling f double dash 2 is greater than f2, so no, they are both equal, so c is incorrect and d is correct. Now we have to check whether it is maximum or minimum at x equals to 2, okay, now see here how we will check it. Now here what we are getting here, f double dash 2, okay, f double dash 2 is equals to f2, from here we are not getting, okay, and what is given in the question, here it is given to us in the question that f maps R to 0 to infinity. That means this is the codomain value, that is the value of y. Okay, and fx denote the value of y. Okay, so here f2 is the value of fx at x equals to 2, and that is the codomain is from 0 to infinity. That means the codomain is always positive, never 0 or less than 0. Okay, so f2 has to be greater than 0. Okay, so f2 is greater than 0 always. Okay, so because fx is always greater than 0, so f2 has to be greater than 0. So f dash 2 will be greater than 0 because f2 is greater than 0. Okay, so f2 is greater than 0, so f double dash 2 is greater than 0. And what we know, that when the double differentiation of a function is greater than 0 at any point, okay, at that point the function is minimum. Okay, suppose at x equals to suppose a, at x equals to a, okay, f double dash a, okay, become greater than 0. So x is equals to a is the point of local minimum. Okay, local minimum, that is the property. Okay, minimum. Okay, so here what we are getting, f double dash 2 is greater than 0. Okay, because f2 is greater than 0, here the codomain is always greater than 0 because it is 0 to infinity. So f double dash 2 is greater than 0, so fx is fx has a local minimum. Okay, local minimum at x equals to 2. So fx has local minimum. Okay, so here the a is saying it has a local minimum at x equals to 2. So, okay, so that is correct. It is not maximum, it is minimum. Okay, so b is wrong. So b is wrong and a is correct. Okay, so what we are getting, the which options are correct? Only a and d are correct and b and c are wrong. So the correct options are a and d. Okay, so I hope that you must have understood the sum very clearly. Okay, thanks for watching the video. Stay fine. Thank you.